In this lesson, we're going to look at solving a parallel circuit, which again means finding the voltage across each one, which is pretty easy in a parallel circuit. They're all the same. Current through each resistor, which is different in a parallel circuit because there's those paths. And then, of course, we can find the power consumed by each thing in a parallel circuit. So let's start with a parallel circuit. We'll draw our battery, and then we'll put in a 30 ohm resistor, 30, and we'll also put in a 6 ohm resistor, 6 ohms. We'll call this one R1 and this one R2, and we're going to go ahead and make say a 60 volt battery. Sounds sufficient. What we want to do is we'll find the current. We want to find the total resistance so that we can find the current leaving the battery. That's going to allow us to double check everything that's going on. Remember, to find the total resistance in a parallel circuit, the total resistance is actually a reciprocal, so it's 1 over R1 plus 1 over R2, but that doesn't give us total resistance. That gives us the inverse of that, so then we've got to flip that whole thing over when we're done. So over here, 1 over the total resistance is equal to 1 over 30 plus 1 over 6. Well, to add fractions, I have to have a common denominator, so to get a common denominator of 30, I'm going to multiply this one by 5 over 5. And so that's 1 over 30 plus 5 over 30, which is 6 over 30. We just add the tops. And so that's 1 over the total resistance is 6 over 30. Now I'm going to do the reciprocal on both sides. So get the total resistance over 1, which is just total resistance, is 30 over 6, which is, of course, 5 ohms. Now what that tells me is when I go to apply Ohm's law to find the current leaving the battery, voltage across the battery is equal to the current from the battery times the equivalent total resistance that we have, RT. I can write 60 equals I times 5, divide both sides by 5, and we see that the current is 12 amps. Now that 12 amps is not the same everywhere. 12 amps leaves this battery, 12 amps. Some of it splits off and goes this way, some of it continues that way. And so we have to figure out how much current is in each branch. Well, this is actually pretty easy. We can still just apply Ohm's law. So now I'm going to apply Ohm's law to each resistor to find the current in each resistor. Well, R1 has a resistance of 30 ohms, so V equals IR. I know the voltage. The voltage is 60 volts because it's connected up to the positive and negative of that battery. So 60 equals, well, R1 is 30, and I, we don't know. I'm going to go ahead and divide by 30. Divide by 30, and I see that I is equal to 2 amps. Now that's different than the 12 amps leaving the battery because only 2 amps goes through here. That means, well, if 12 comes out, there must be 10 over here, but we're going to double check that by applying Ohm's law over there. So for resistor 2, we apply Ohm's law and we see 60 because the voltage everywhere is the same in a parallel circuit is equal to IR. I is unknown. The resistor of R2 is 6, or resistance, divide by 6, and I is equal to 10 amps. And so that's good. That's exactly what we wanted to see because it matched our equivalent resistance and the current that we got from that. So 10 amps plus 2 amps is 12 amps. So 2 amps come through here, 10 amps come through here, they meet back up, and now we have 12 amps returning back to our battery. Now, all we have left to do is find the power. Remember, power is voltage times current. We know the voltage and we know the current through each one. The voltage across each one is 60. So R1 has a power of 60, which we'll call P1, times its current, which we know is 2, and that is 120 watts. And then for R2, we have power 2, which is equal to its voltage, which is still 60 because the voltage everywhere is the same in a parallel circuit, times its current, which is, of course, 10, and that's 600 watts. That gets me a total of 720 watts dissipated in that circuit, which better mean the battery is producing 600 or 720 watts. Well, the power of the battery would be equal to the voltage of the battery. That's an equal sign. Voltage of the battery times the current delivered by the battery, which is 60 times 12, which is 720 watts. So it does check out. Power is being consumed at the same rates being produced. Energy is conserved. Everything there looks good.